Hello viewer, this is Selim TV. Welcome to Form2 Physics, our lesson number 2. The topic is magnetism, and today you're going to look at magnetization and demagnetization. I'm going to be your teacher, Benjamin Makanda. Welcome. So before we begin our lesson, let's look at the specific objectives that we have to achieve by the end of the lesson. And by the end of this lesson, the learner should be able to describe various methods of making magnets, that is magnetization. The learner should also be able to describe the various methods of demagnetization. So the lesson aims at understanding magnetization and demagnetization. So the order of the lesson is going to follow this order. Lesson preview, we are going to look at review of lesson 1, and at this point, let's just have a glance of what we learned in lesson 1. We defined what magnetism is and also looked at types of magnetic materials, and we also looked at properties of magnets. Now, considering that we want to relate what we learned in the first lesson with this lesson, especially the properties of magnets, which are going to be very important as far as this lesson is concerned. Now, so what we're going to learn in this lesson, we're going to look at description of various methods of making a magnet, and we're also going to look at description of the process of demagnetization. Then lastly, we are going to look at the assessment. Having gone through all this, we shall look at some of the questions that will help you understand the lesson even better. So up to that point, I want to invite you into the Elimu lab for us to look at the various methods of magnetization and demagnetization. Come to the lab with me. See here, we have a steel bar, and then we have two bar magnets that are being dragged on the steel bar. This method of demagnetization is called double stroke or double touch method, because we are using two magnets and we are pulling the magnets away from one another. We call it double stroke or double touch magnetization. So we have to repeat the dragging process on the bar so that it attains magnetism. So then at the end of it all, you realize the poles are going to be opposite. Now the bar there is able now to attract iron material. The steel bar attracts the nails, showing that it has acquired magnetism. Now that method we are saying is called double touch. So methods of magnetization in summary, the methods include single touch method, double touch method, and electrical method of magnetization. These are the methods used to make a magnetic material become a magnet. Now, demagnetization is the process of removing the magnetic property from a magnet, opposite of magnetization, and the methods include rough handling, heating, induction, and passing electricity, as we're going to see later on. Now, these are 4 methods of demagnetization, and we've also looked at the 3 methods of magnetization. Now, moving on, let's look at this method of magnetization, and this is the single touch method. Now in the single touch method, we have soft iron piece, as you can see it here, and then we have the bar magnet. Then what happens here, we incline the bar magnet on the iron piece, steel iron, and then we keep on dragging from point A to point B. We drag from point A to point B. Once you reach point B, you will lift it. And we do this one repeatedly several times. And then look at the poles. We have the North Pole and the South Pole. So, what does the poles tell you? They actually tell you that the last touch, where the magnet last touched, acquires the identical pole to the magnet. So that North Pole will be at the point A, because that's the last part where the magnet first touched. So that method is called single touch method. Let's now see here. So the material is able to attract, the soft iron piece attracts the nails, showing that magnetism is induced in it. So it has acquired magnetic property. So that one is single touch. So this one is double touch method, and we are saying the double touch we use to magnets. So we have a steel bar placed on 2 magnets with opposite poles facing together, facing one side. So those are bar magnets. Now we want to start. So the steel bar is resting from point A to B. So you drag from the middle of the magnet to the ends A and B respectively. Yeah, that's what you're doing. We keep on dragging repeatedly until all the magnetic materials in it are completely aligned, as we're going to look at it later. So we keep on dragging until all the magnetic materials are aligned. So the poles of that magnet are north-south. So let's test whether it's magnetic. Yeah, iron nails are attracted. The steel bar attracts the nail, showing that it has acquired magnetism. And again, we have said this method is called double touch. Now, the other one that we want to look at is electrical methods of magnetization. So here we have to wound a wire to form a coil or a solenoid and place it on a rigid support, then a soft iron bar, insulated copper wire, then we connect it to a battery, which is a source of direct current. Now, at that click here, we are now locating the flow of the current. That's how the current is flowing within that coil. And as the current flows, it induces magnetism in the bar AB. So just observe the direction of flow of the current. So that direction is going to determine the poles of the material AB. So back. So the first end, A, acquires the south pole. The other end acquires the north pole. So if you observe from end A, it is the south pole. When viewed from end A, as we can see there, we acquire the south pole, and when viewed from the end B, the current is found to be flowing in anti-clockwise direction, and therefore B attains a north polarity. Now the anti-clockwise direction becomes the north, and the clockwise direction becomes the south, depending on where you observe from. So that one is determined by the flow of the current. So this is the electromagnet case. To be a magnet, as soon as the current is stopped, the magnetic property in it is lost. So if you place some iron fillings close to it, they are attracted. They get attracted to the bar, meaning that it has acquired magnetism. And then when the current is cut, the magnetism is lost. So this one is a temporary way of making magnets. So methods of demagnetization, we have rough handling, by heating, by induction, and by passing electricity. So these are four methods, and yet we have seen electricity can also be used in magnetization. So this one are some of the methods that we use in doing what? In demagnetizing a material. And we have one here. This is a method of magnetization. This rough handling, actually, you take a magnet and then you drop on the rough surface, so it loses magnetism. Then here we have heating. When you heat a magnet, you do some heating on a piece of a magnet or a magnetic material. A magnet is going to lose its magnetism if heated above a certain temperature called it is Curie point. The point at which a magnet loses its magnetic property, we call it the Curie point. So we just have an example here. Iron will lose its magnetic property at 770, steel at 880, nickel 358, and cobalt at 1121. So the other method, magnetization, is by induction. Now in induction, the magnets lose their magnetic property by actually a mutual force of repulsion or attraction. A mutual force of repulsion or attraction, as we can see from this diagram, they just lose. These two magnets are not in contact, and yet the impact is making them lose magnetic property. So how do we prevent this? We keep them in the magnetic keepers. So those are the methods that can be used to demagnetize. The last one here is now the electrical or electricity. Use of electricity. The arrangement is similar to that one of magnetization, but now in this particular case, we arrange the material to be magnetized to face in the east-west direction. We still use insulated wire, copper wire, and then now that's the direction of the flow of the current. We have the south and the north pole. Now, let's come back to our class. So we have had a short experience in the lab, the process by which a magnetic substance attains magnetism temporarily or permanently. So a magnetic material can either be temporal or permanent. Some of the methods used to make magnets include the following. One, we have stroking or touching method. We have learned that in the lab. We have electrical method, is yet another method of making materials magnet. Then we also have hammering. It's another method of making a material a magnet. The last method in this case is induction. These are methods that are used to make a material a magnetic material. So moving on, We now want to look at these methods one by one, and the first one is electrical method. So from our discussion in the lab, this method is used to make permanent magnets. And one thing about this method is that magnets are usually magnetized by putting them into the coil. That coil is called a solenoid of wire, and passing a large direct current through the coil for a moment. So we use direct current for magnetization, but not alternating current. Direct current flows in one direction. We will understand why we're not using the alternating current. So the current used in electrical method is the direct current. That's one thing we have to note here. Now, the polarity of the magnets produced depends on the direction of the electric current. We also saw that in the lab, that now, if you want to determine the polarity of a material within the solenoid, you look at the direction of the flow of the current. If that end of the current shows that the current is flowing in and clockwise the direction then that end becomes the north pole of the magnet. And if that end shows the direction of the current flowing in a clockwise direction, then the end becomes the south pole of the magnet. Now, electrical method still, we have said the method used to make permanent magnets, that's one. And magnets are usually magnets by putting them into the solenoid of wire and passing a large direct current of electricity through the coil for a moment. The polarity of the magnet produced depends on the direction of the electric current passing through the coil. We have seen that, and let's just have an appreciation of this through this diagram. So the diagram here is able to explain to us. Now look at the ends. So that's the flow of the current, and at the point D, the current is flowing in a clockwise direction, and therefore that end becomes the south pole of the steel bar. The other end shows that the current is flowing in a clockwise direction, and therefore that end becomes the south pole of the north pole, of that particular magnetic material. So this diagram can help you explain the observation that we made in the lab. So you can actually be able to look at it and understand that. So D is the south pole, and the other end here is the north pole because the current is flowing in anti-clockwise and clockwise direction. Stroking is yet another method of making a material a magnet. And what is stroking? Stroking produces magnets that are not strong as the electrical method. This kind of method produces magnets that are very weak because they don't align all the magnetic materials. So the other thing about stroking is that the method is also known as the touching method. You have to touch the touching method. So when you talk about stroking, you are also touching. It's the touching method. And from the experiments we have done in the lab is that in stroking, you drag a piece of magnet on a material to be magnetized. Now, two of these methods are used. We have two of the stroking methods that are used. One of them is called single stroke or touch. That's the first one. The other one used is called double stroke or touch. These are two methods used for stroking. So we want to begin by looking at single stroke or touch as a method of magnetization. Now, what is single stroke or touching? A magnet is drawn over the rod so as to go completely over the length of the rod, as we saw in the lab. Then another thing, magnetic domains are then pulled into alignment as the magnet passes. So I will just repeat this. Magnetic domains are then pulled into alignment with as the magnet passes. This means that as you continue passing the magnet on a magnetic material, we have regions called the magnetic domains. These regions consist of small submagnetic materials called the dipoles. So the dipoles get aligned in one direction. This term here, alignment, means that all the dipoles are going to face in one direction. And once the dipoles get aligned or face in a given specific direction, particularly north-south direction, then the material becomes a magnetic material. That's what we mean by this point. So the other thing that we have to note about single stroke is that the end of the rod last touched by the magnet acquires polarity opposite to the one touching it. So that end that was last touched acquires actually the polarity opposite to the one touching it. So if the last end was touched by the north pole, is going to acquire the North Pole than the one that touches it currently. So let's have it here. So this is a photo showing single stroke touch, and then in the single stroke we have AB is the steel bar being magnetized. Now look at the direction of stroking or touch, moving from point A to B. So the last end that was touched, it was touched by the pole M. Therefore that end becomes the North Pole, and therefore follows that the other end is going to become the South Pole. That is a single touch as a method of magnetization. So you can have this diagram. A close view of the diagram is able to tell you this. Now, the other method is called double stroke or touch method. Double means that we are using two magnets. Now, it is also known as divided touch. We are dividing, actually having two magnets. And then in this method, two magnets are used at the same time in what may be thought to be as a mirroring action. So we have something like a mirror. These magnets are identical. So it's like a mirroring action because we're using two identical magnets to make a magnetic material become a magnet. So the other thing about double stroke is that the process produces a stronger magnet than the single touch method because we're using two magnets, and therefore the reason why the magnetic material made here is much stronger than in the latter is because in this particular case the two magnets actually concentrate the poles or the magnetic lines or forces together, making the material become a strong magnet as compared to a single touch method that we've just observed. Now we can have this view here. This is a view of a double stroke or touch method of magnetization. We have point A and B. So starting from point A, so that South Pole starts from the middle, and therefore it makes the point A to acquire the opposite pole, which is the North Pole. Then on the second magnet, it starts from the North Pole and ends at B. It gives that end another opposite pole, which becomes the South Pole. So that in this particular case, we have a magnet that is North Pole and South Pole. So this one here is what we call double stroke as a method of magnetization. Now this method is very interesting because if you magnetize a magnetic material using this method, then it can give you a magnetic material that has two identical poles at the end. This magnetic poles or magnetic material that has two identical poles at the end acquires a special name. And what's the name of it? Look at this. Yeah. Yes, let's move up with that. So it acquires the poles called consequent poles. It acquires consequent poles. So we have just noted one thing, that double touch will give you poles that are consequent in nature. So what are the consequent poles? So consequent poles are acquired if the double stroke method is done using two similar poles facing the bar. It is possible to create a bar magnet with the two like poles at either end. The two like poles appear at the either end. They can be either south-south pole at the end of the magnet or north-north and poles at the end of the magnets. So those poles that are identical at the end of the magnets are what we are calling consequent poles. This one can only be achieved if you use a double touch or a double stroke as a method of magnetization, but it's not possible with single touch method. So these are this phenomena where we get poles that are identical at the end. We call it a consequent pole, as we have seen, and then we can be able to appreciate it from this diagram here. Now at the middle, we are starting with south-south. Then at the end of the steel bar, it acquires poles that are identical. They are similar. We have north-north at the end, and in the middle of the bar material, we have what? We have the south-south poles. So these are the poles we are calling the consequent poles. So a close view of the diagram is able to explain this to you. You are able to understand that one. Now we proceed on. We look at the other method of magnetization, and this one is hammering. And what is hammering? In hammering, steel can be magnetized to a certain degree by placing the bar in the north-south direction and you hammer it. So you take a steel material, steel is a magnetic material, and let the steel face in the north-south direction. Then continuously hammer that material. To some extent, the magnetic material within steel are going to be aligned such that steel is going to acquire temporary weak magnetic property. So actually this method of magnetization gives a magnetic material a temporary magnetism, and the magnet that is formed out of this rather is a bit weak compared to the other two methods that we have discussed. Then ships become magnetized in this way during manufacture, as the hammering allows the earth's field to magnetize them slightly. Actually, hammering take advantage of the magnetic influence of the earth. You know, the earth is a big magnetic material. Naturally, the earth is a magnet, and therefore, when you take a magnetic material and continue hammering it facing the north-south direction, then the material acquires magnetism. So it takes advantage of the earth's field to magnetize it slightly. It's not a strong magnetic kind of thing. Now, this is what we do. Like in this particular case, we are hammering these materials so that by the end of it all, this material will have been magnetized. It will become a magnet. It will become a strong magnet. So we keep on hammering the material until it acquires magnetism, because the dipoles are going to be aligned. Now, magnetization by induction is the last method of magnetization, and magnetic by induction is the process of inducing magnetism in an ordinary piece of magnetic material. Later on, we shall look at the working of transformers and how they are designed. Transformers work on the principle of magnetization by induction, what we call electromagnetic induction, because magnetism is induced in them by induction. Now, what about this? Induction involves placing magnetic material, and this magnetic material should be soft iron close to a strong magnet without touching. The two materials ought not to touch for them to acquire magnetic property. Now, this is an example of induction. These pins have acquired the north poles rather, at their ends by induction, so that when you bring another bar magnet close to them, they repel, meaning that they've been magnetized by induction, and that's why we have that kind of repulsion. Now, moving on, we have this pin here showing that it has acquired actual magnetization, the opposite poles at the end, and the other end at the north pole, we have the south pole, because the poles of the magnets that are alike attract. So we have a look at that. We have repulsion indicating that the pins have been magnetized by induction. So we also have this soft iron bar becomes induced by magnet, with the end near the magnet having opposite polarity to that of the magnet, so that by the end of it, induced magnetism is temporary process. If the permanent magnet is removed or withdrawn, the magnetic material will usually lose its induced magnetism. Actually, this one is a temporary kind of magnetism, and that's why in most cases we have power surge, we have power blackout, because transformers operate on the principle of induced magnetism. And once the electric current is cut, then you don't have electrical method of magnetism, and therefore the temporary magnetism in the transformers is lost. So induced magnetism can actually be explained by the use of a transformer. But in our case here, let's again look at this diagram, which further explains how induced magnetism is actually achieved in this case here. Having said that, we now want to move to demagnetization, which is the opposite to magnetization. And we are saying demagnetization is a method of actually making a magnet lose its magnetic property. When a magnet is made to lose its magnetic property, then that process is what we call demagnetization, actually the opposite of magnetization. And how can we make a material become demagnetized? We have a summary of some of the methods that can be used to demagnetize a magnetic material. One is by, let's look at some of these methods. Electrical method, and in electrical method, placing a magnet in a coil placed in east-west direction and passing an alternating current demagnetizes the material. So the current must be flowing from the east-west direction, and which current should be this? Should be an alternating current, AC current. The current that keeps on changing its terminals can make a magnetic material lose its magnetic property. That's one. Number two is by heating a magnetized material until the red hot, and cooling it suddenly will make this magnetic material lose its magnetism, especially when resting in the east-west direction. it loses its magnetic property. Then the last method of demagnetization is hammering, and in hammering, a magnetized material placed in the east-west and then violently dropped makes it lose its magnetic property. This is because when you actually release a magnetic material violently, what happens? You are actually disarranging the dipoles, the magnetic molecules within it, and therefore the disarrangement of the dipoles of magnetic molecules make this material lose its magnetic property. Therefore, in summary, these are some of the methods that can be used to magnetize a magnetic material. Now, up to there, I hope and believe you have enjoyed your lesson. We have had 2 sessions. The first session we visited our lab, and you must have realized that our lab is very exciting. Then the second session we came back to our class and we've discussed the observations that we made in the lab. So up to that end, I want to leave you with some work that you will attempt at your own convenient time, so that when we meet in our next lesson, we shall be able to review this work. So this is what you're going to do for me. You describe an experiment to show that, to show how to make a magnet by single stroke method, electrical method. Then the next question, explain the following terms: consequent poles, self-magnetization, magnetization by induction. So this part of the work that you're going to do. And the last point on question 2, you also define ferrites. What are ferrites? So these are some of the work that we've gone through. So you will look at the questions, which will help you understand the lesson even better. Until then, I've been your teacher, Benjamin Makanda. Continue watching LMTV. Thank you very much.